Good afternoon. We're going to tackle tissue level of organization part 3. This is our final section of this chapter. We're going to be discussing muscle, nerve, tissues, and injury repair as well. How a callus forms, how a scab, the function of a scab, and how we can repair our tissues. And here we've got an opening slide, a picture of a starfish that has obviously lost a leg in a battle with, say, grouper, some other undersea predator that is taking a couple of its legs off, and now it's growing new legs. And it's incredible that this creature has that ability to do it. Start out with muscle. There are 3 types. Okay, there's skeletal muscle, cardiac muscle, and smooth muscle. A key, very important something for you to know is that only one of these 3 muscle types is voluntary. Only one we can control, and of course as we squeeze our beach muscles, as we flex our abs, we know that skeletal muscles are under our conscious control. But cardiac muscle, we don't tell our heart when to beat. The heart just beats automatically, and there are cardiac rhythm centers that are within our brainstem that help regulate all that. There's an electrical system that's harnessed into the heart, and it is dependent upon, let's say when we get stressed out, that's an involuntary thing as well. Hormones are mediating that, nerves are throttling up, and the heart rate can increase. But largely, cardiac muscle is involuntary. Smooth muscle as well. You see a picture of the stomach here. Inside the stomach walls, its churning capability is made possible by smooth muscle. As you can see, the different structures of these muscle tissues, they are quite different. And because their structure is different, we can assume that their function is going to be somewhat different as well. But all 3 do contract and perform that function, specialized function within its tissue. Here's an example of skeletal muscle. Skeletal muscles have striations, so you can imagine a bodybuilder, when somebody says they're cut, you know, that guy's really cut. Look, he's got sculpted ab. You can see the striations, these little bands, or groups of them anyway, within the muscle belly as somebody flexes. Somebody that's very, very lean. There's not a lot of adipose tissue overlying these muscle fibers, so we can see them at work. So skeletal muscle is specialized for concentration. It is a voluntary muscle action, so we can control it. And the cells that produce more muscle fibers are called myosatellite cells. There are also multiple nuclei, so more than one nucleus within these cells. You'll want to know that. Cardiac muscle has some features. Let's take a look at its structure. It's not as clean. If you could focus again on skeletal, you can see that this is pretty straight, these fibers, whereas the cardiac muscle is branched. So it's got, there's one fiber goes there, and this fiber kind of goes down like that, and then this one over here is kind of askew. So they go a little bit off the beaten path, not as straight as skeletal muscles. You also have these things right here which are called intercalated discs, and they hold the muscle fibers together, and they help propagate and perpetuate the electrical stimulus, and therefore the contraction. So all of these cells are connected by like little junctions, like little electronic junctions that allow them to all work together. These muscle cells are also known as cardiocytes. Cyte means cell, right? Cardio means heart. So you're only going to find cardiac muscle cells in the heart. They are striated as well as skeletal muscle. They are also involuntary, so we cannot control them. Smooth muscle and cardiac muscle are involuntary contracted. There are cells called pacemaker cells within them that help maintain the contraction, so that help us keep the beat within all these different cells that again are held together by these intercalated discs. Smooth muscle is right here in this section, from here to here. That's what smooth muscle looks like in its longitudinal presentation. Here we've cut that smooth muscle and turned it the other way, so we're looking at it on end. And so we've got, it's a non-striated muscle cell, so therefore it is smooth, right? And they do divide, they can regenerate after injury, whereas at least in the case of the cardiac myocyte or the heart cell, they have a more difficult time doing that. They don't seem to repair themselves as well. Here's an example, textbook example of a nerve. We've got the same cell membrane and organelles, but there's different structures to this tissue. Neural tissue or nerve tissue, it's going to consist of neurons and neuroglia. Neuroglia are these little dots right here. These nuclei represent little cells, and they're support cells. They support this larger neuron, its function. So the function of neural tissue overall is to respond to stimuli. It's to send messages, electrical, chemical messages, and impulses throughout the body. There are some nerves that are a meter long, so that's pretty crazy. The neural impulse is otherwise known as the action potential, and we're going to talk a lot about that going forward. Neurons are specialized cells that propagate electrical current, so they're like little wires. Different parts of the neuron. This is the cell body. We can tell that because it's got the nucleus in it. And then these things coming off the sides are called dendrites. They're like little roots or trees that can reach out to other nerves and connect. And if you can remember, think back to that video that we based our discussion on stem cells transforming into nerve clusters during week 2. This kind of looks like that video a little bit. So all these connections via dendrites with other cells, and they're sending electrical messages. The cell body is otherwise known as the soma, and the axon of this long strand right here is like the wire. That's called the axon, or the nerve fiber. An example of some neuroglia. These microglial cells, astrocytes, oligodendrocytes, they all perform different functions. So the oligodendrocyte, for instance, wraps around the nerves, creates a sheath, and that's like the insulation on a wire. So it helps transmit the electrical impulse or the action potential. It's like an insulator. And then the astrocyte is going to supply nutrients and provide support framework within the neural tissue. Microglial cells clean up the area. So how do tissues heal? Our basic definition of homeostasis is to maintain that constant internal environment. That's how we keep the body running, and that happens from a chemical level on up. Chemical, cells, tissue, organism, yes. So inflammation and regeneration are essentially how tissues are going to bounce back from injury. And here's a continuum, an example of, let's say, muscle tissue that's, you're working out at the gym and you pull a muscle. There's going to be some inflammatory cells that are going to go into that area, and they're going to contain that injury. And while some cells are building the tissue back up and repairing it, others are fending off the any bacteria that might enter the area, or cleaning up the products of blood, bringing nutrients, bringing scar tissue, and then you can see the inflammation will eventually start to leave that area. The cleanup crew is done, and what they've got left is a muscle structure that looks pretty much like it had previously. Another example of chronic injury here, we've got a muscle that's not working correctly. So there's chronic inflammation. All these little dots are cell nuclei that are cleaning up the area and repairing the muscle tissue. And then we get a scar at the end, and another word for scar is fibrosis. Here we have an example of a splinter entering through the skin. This is stratified squamous epithelium, and this splinter is piercing all the layers there, and as a result of that injury, there's going to be some chemicals that are released that are going to attract white blood cells to come and clean up the area, gobble up foreign material, rearrange the structure, provide nutrients, and otherwise heal the area. Platelets are going to come into the area, and platelets, we all know that their function is in clotting, so they'll help if there's a bleed here. Platelets will go and migrate to that area, and then once the tissues have healed, the platelets will be resorbed back into the system, and the inflammatory cells will subside and go off to fight another battle. Here's a picture of somebody who cut their finger off, their fingertip, and it looks like it's regenerated pretty well. So regeneration is a repair process that restores function as normal as it possibly can be expected given a particular injury. What I'd like you to take away from this slide is that with advancing age, we lose our ability to repair tissues. We retain it to some degree, but as you can see, your nerves don't transmit messages as quickly. Your heart rate is unable to reach its maximum capabilities. Your kidneys don't filter as readily. Your breathing and your oxygenation of tissues is not as effective and efficient. And the amount of work you can do, essentially all of the elements of healing and maintaining maintenance of homeostasis can't be counted upon as much. Cancer is otherwise known as neoplasia or new growth. About 3/4 of neoplasia is caused by exposure to chemicals or other environmental factors. Cigarette smokers, people that work in hazardous environments have the odds stacked against them in terms of their susceptibility to neoplasia. And that concludes our review of our tissue lecture 3 content. Absorb this information. I'll be conducting a review for our exam, which is going to be 1 week from Tuesday. Have a good day.